We are Kit 8!
Activity 1. Printing text in the serial monitor. We display the hello student repeatedly on the serial monitor. At first, there was no output, but we fixed it by checking the bound rate and reconnecting the board. This activity taught us how to test a serial communication between Arduino and the computer. Activity 2. Showing a temperature readings. We use an LM35 sensor to show a live temperature readings. The data fluctuated, so we established the sensor and checked the wiring. This is a useful and temperature monitoring system and digital thermometers. Activity 3. Checking if the button is pressed. This activity detected button press and showed the message on the serial monitor. It didn't work at first, but we fixed the wiring and used an input pull-up mode. This can be applied in the control panels and manuals input devices. Activity 4. Serial monitor as a remote control. We control an LED by typing 1 or 0 in the serial monitor. The LED didn't light up at the first due to loose wire, which we reconnect properly. This is a useful in smart control system. Activity 5. Light sensor logging. We use a photoresistor to measure and record a light intensity. The reading changed too quickly, so we tested it under the steady light. This is a use in automatic lighting and solar tracking system.
Activity 1 Distance Measurement Display Version 1. We measured distance with an HCSR04 sensor and viewed result on the serial monitor. Some readings were inconsistent, so we aligned the sensor with an object. This is useful in obstacle detection and distance measurement tools. Activity 2 Distance Measurement Display Version 2. This activity displayed measured distance on an LCD screen. The LCD didn't show data at first, which we fixed by adjusting the I2C address. It's used in rangefinders and digital measuring devices. Activity 3 Obstacle Detector. We built a simple detector that lights an LED when an object is nearby. The LED flickered unnecessarily, which we solved by adding a short delay in the code. This system is used on automatic doors and robot obstacle sensor. Activity 4 Parking Assistance System. We simulated a car parking sensor using LEDs and buzzer to indicate distance. The buzzer tones were off, so we corrected tone frequency in the code. This is used parking sensor and distance warning system.
Activity 1 Black and White Detector. We use an IR sensor to identify black and white surface based on reflected infrared light. It had trouble detecting color differences, so we adjusted the sensor distance. This is applied in line following robots and color sorting system. Activity 2. Proximity triggered siren. The IR sensor triggered a buzzer and LED. When an object was detected, the alarm stayed on too long, so we adjusted the sensor sensitivity. This setup is used in motion, alarm, and security system. Activity 3. Count the passers. We counted objects passing in front of IR sensor and displayed the total on LCD. It missed fast-moving objects, which we fixed by adjusting the sensor angle and distance. This is used in people counters and automated entry system. Activity 1. Button-controlled motor. We used a MOSFET and push button to control the on and off function of a DC motor. The motor didn't start at first due to wrong MOSFET wiring, which we corrected by checking the gate, drain, and sources connection. This setup is used in automated switches and electronic motor controllers. Activity 2. Speed control with potentiometer. We controlled the motor speed using a potentiometer that set PWM signals to a MOSFET. The motor failed to spin smoothly at lower levels, so we adjusted the power supply and remapped analog values. This circuit is applied in fan regulators, dimmers, and variable speed robotics.
Activity 1. Motor power control. We control a DC motor on and off state using an L293D H-bridge. The motor didn't run at first due to wiring errors, which we fixed by reconnecting the power and ground. This can be used in simple automated systems like fans and conveyor. Activity 2. Motor speed control. The motor speed was varied using PWM signal, and the struggle we experience is unstable motion, followed by securing loose wires. It's applied in motorized toys and robot for speed control. Activity 3. Motor direction control. We changed the motor direction using logic signal from the Arduino. It initially spun in the wrong way, so we swapped pin connection. This is used in robotic and conveyor systems. Activity 4. Push button motors direction control. To push button control the motor forward and reverse direction. It's sometimes delayed switching, so we check button wiring. This setup is used in lifts and remote controlled cars. Activity 5. Direction and speed control with buttons and potentiometer. We use button for direction and a potentiometer for speed adjustment. The motor speed was uneven, which we fixed by recalibrating the potentiometer. This can be applied in drills, robotic arms, and motor tools. In our robotic lesson, we learned how to control and monitor different components using Arduino. The serial monitor taught us how to display data and send commands, while the ultrasonic and IR sensor help us detect distance, light, and motion. The H-bridge and MOSFET lesson showed us how to control a DC motor's direction and speed safely. This activity improved our skill in wiring, coding, and troubleshooting, give us a solid foundation for creating real-world automation and robotics system. Through our robotic activities, we gain a deeper understanding of how electronic and programming work together to create automated system. Each experiment helped us connect theory with practice, from using the serial monitor for communication to controlling sensor and motor with precisions. We realized that even small details like wiring or code can affect how a project functions, teaching us patience and careful attention. The challenges we face, such as unstable reading or converting errors, became valuable lessons in problem solving and teamwork. Overall, this experience strengthened our creativity, critical thinking, and confidence in building real world robotics system, inspiring us to explore more about automation and engineering in the future.